Here we've been asked to graph f of x equals log base 2 of x and g of x equals 2 to the x power by creating a t-chart. We have also been asked how these two graphs are related. First of all, we need to know that a log function is the inverse of an exponential function. Specifically, you must have the bases being the same. So in this example, we notice that we have two functions. We have our log function and we have our exponential function. The log function has a base of 2 and the exponential function also has a base of 2. These two graphs are inverses of each other. So we can go ahead and say right now that the two graphs are going to be inverses of each other. Now, knowing that, here's what we're going to do. At the moment, we know very little about a log function, except that it's the inverse of an exponential function. In an earlier section, we learned how to graph an exponential function by creating a t-chart. Because I know inverse means switch the x and y coordinates, I'm going to create a t-chart for my exponential function that I know something about, and then I'm just going to switch the ordered pairs for the log function. Earlier in the notes, we talked about creating this t-chart for the exponential. And in that t-chart, we chose -3, -2, -1, 0, 1, 2, and 3 as our x values. Okay, I'll do this. Basically, again, I'll plug in the x values into my 2 to the x. And we've done this before, but I'll do it again. So 2 to the -3 is 1 over 2 to the third, which is 1 over 8. So the ordered pair is -3 and 1/8. 2 to the -2nd is 1 over 2 squared, which is 1 over 4. So the ordered pair is -2 and then 1/4. 2 to the -1 is 1 over 2. So -1 and 1/2 is the ordered pair. 2 to the 0 is 1. So 0, 1. 2 to the first is 2. So 1 and 2. 2 to the second is 4. So 2 and 4. And then 2 to the third power is 8. So 3 and 8. These ordered pairs is for my exponential function 2 to the x. Because the log function is the inverse, I will simply flip the ordered pairs. So 1/8 and -3, 1/4 and -2, 1/2 and -1, 1 and 0, 2 and 1, 4 and 2, and finally 8 and 3. Okay, and then from here they want us to graph these two functions, and I'd like you to do it on the same set of axes. Okay, first of all, for the exponential function, we know that the exponential function has a vertical asymptote along the x-axis. So I'll go ahead, I'll sketch that in. That's the line y equals 0. Okay, and then I can go ahead and plot the ordered pairs that I have from above. Some of these I just kind of have to do the best that I can. Let's do these in red. So -3 and 1/8 is just going to be very, very close to the x-axis. -2 and 1/4 will also be close, but not quite as close. -1 and 1/2, we can kind of see that. And then 0 and 1, we can definitely plot that point. 1 and 2, 2 and 4, and then finally 3 and 8. Okay, and this graph fits what I know is the basic shape of an exponential function. Okay, I'm going to do the logarithmic function in blue. A logarithmic function from an earlier slide we know has a vertical asymptote along the y-axis. So I'll go ahead and sketch that there. That's at x is 0. Okay, go ahead and try to do the best you can with the ordered pairs. First ordered pair is 1/8 and -3. 1/8 is the x value, -3 is the y, so that means that it's very, very, very close to the y-axis at -3. 1/4 is the same way, not quite as close. That's at -2. And then 1/2 and -1 would be somewhere in here. Okay, now x is 1, y is 0. X is 2, y is 1. X is 4, y is 2. And then x is 8, y is 3. And then we can sketch that graph. We get close to the y-axis down below, and then we increase, go up and to the right in the direction of the x-axis. Now, we can see that these two graphs are inverses of each other, which is the way we produce them. If we look at the line y equals x, we see that the two graphs are reflections across that line.